Okay. Hi everyone. Yeah, can you hear me? Great. Buongiorno. So I hope that everyone's feeling great today. Today we will talk about the Node microservices, and this is a definitive guide about how to build Node.js microservices, how to scale them, and some best practices that I've learned over the years. This is, of course, Node microservice definitive guidebook, or really, and this is our animal. So I'm Jovanovic. I work as a software engineer at Nearform, and in my free time I'm also maintaining JS remotely. It's a website for JavaScript remote jobs. You can find me on Twitter, and I'm writing about microservices and JavaScript in general on my blog. So, how many of you really know what are the microservices? How many of you use them? Oh, cool. How many of you do backend development? Okay, so looks like all backend developers know what are microservices. I want to start from the beginning. So let's see first what are the microservices. So microservice is an architectural style that structures an application as a collection of a loosely coupled services. So what? Yeah, this is a definition from the Wikipedia. So let's do a simple introduction. This is our usual monolith Node.js app. So this is an app, and it's living on some server. It has tests. It has probably not model view controller pattern, and this is a database. So this app can also look like this. So those are the small apps, and each of them has a database. So those are our loosely coupled services. Loosely means that they don't depend on each other. So they're really independent. They can be deployed separately. They can live separately. And if you for example, depend service on each other, you're again creating the monolith structure, because you will have separate services that need to live with others. And at the end, you have the same thing, the monolith app. Services can need to communicate together, and for the communication we usually use event bus. So the architecture usually looks something like this. We have the event bus, and the services can send the message, can receive the message, and that's the way how they communicate. So the event bus allows us to have the publish-subscribe style communication between components, and we don't require them to be registered one with another. So you have a service that doesn't know anything about the others. It can think that it's the only service in the system, and her only job is just to live there, connect to the event bus, and wait for a messages. When the message comes, do something, send a response back. So some microservice principles are first thing, we need a lightweight protocol between services. So we need something that's simple to use, usually some kind of event bus. People also use HTTP. So that's something that's already there. You can use REST API, and services can communicate using the REST. But I prefer event bus, and in the next slides I will show you why. Next thing, we want small services. So I've read somewhere that some famous guys recommend that in Node.js each service should have a maximum 100 lines of code. So I mean, you can do whatever, as many lines you want, but it's required that your service has one job. That's easier to test, deploy, and to work with later. Next thing, as I said at the start, we want service independence. So the services that can live alone, can be deployed alone. Next thing, microservices are here to help us to easily deploy our, create our application. It shouldn't make things complicated. So the whole architecture should be easier to understand, easier to develop and test. Because imagine that you have one big monolith app, then you have to onboard a new developer. When he goes inside the code, you tell him, for example, update the registration flow to include two-factor authentication. He will then need to browse the code to set up everything, to run all tests, to maybe install a couple different databases, to run the migration, all those things, and that really takes time. In a microservice architecture, you will probably have one small registration service, and the job for that guy will just be to go through the documentation to find what service is responsible for registration, to pull the code down, easily run the tests, check that 100 lines of code to see how that works, and to easily just add new code that will do the two-factor authentication. Then he will, in no time, he will create a pull request, and your code will be in your master branch and deployed to production. That's the thing. So we use microservice architecture to speed up the development, because with a good documentation, you immediately know how are the other parts of the system working, and when you have a task, you know what part you need to update, and it's really so it's easy to execute 20 tests than 10,000 tests in some monolith app. And this really enables us to do the continuous delivery in deployment. So whenever some service is ready, you can push that to a continuous integration service. You will see if the build fails or if it's green, and with the push of a button, you can easily change the service that's already running on a production with a new one that you created, and that speeds up the whole process of the development. And on the other side, with the monolith applications, I work in a company where we had a big monolith app with 20,000 tests, and after every iteration, we were doing the production deployment that took almost whole day, because the whole build of the running tests, and if something goes wrong, then you need to pull code down, then try to figure out what's wrong. With the microservice architecture, you really have those smaller parts. If something goes wrong, you can just go inside that smaller thing and see what's wrong, push again, and deploy. So now we know what exactly is a microservice architecture, why I recommend that, why is it new good architectural style. So let's see why I recommend using Node.js for building microservices. Of course, because we are JS developers, but there are a couple more things. So Node.js is small and lightweight. So as everyone knows, for running Node, you just need a Node runtime. It will install the V8 machine, and you will just need one file and Node command to execute that file, and that's basically it. It's small. It doesn't require a lot of things to make it run. Like for example, Java, you need to build it, then execute, and so on. Next thing, there is no boilerplate code. So the Node.js at the start comes with a lot of modules that you can just reuse and create your services. You don't need anything else there. Non-blocking I/O. So one of the most famous feature of a node. You want your service to be non-blocking. So imagine a service, then event bus or HTTP protocol standing in the middle of services. When you ping your service, it will immediately return the results. If you ping it a couple times, then each of them will be processed and returned back. So if some error happens, there is no blocking the whole system. And the speed. So Node.js is fast. You can check benchmarking, especially the latest 10 version. With microservices, you really want your services to be fast, and if some service becomes slow, your whole system will be slower. So it's really important that you have optimized services and that they are running on something that's really fast. And that's the last thing is freedom. So the Node.js community is really big. The Node.js itself comes with a lot of modules that you can use. If you want to use something else, you have really whole freedom to to do whatever you want there, to use whatever modules you have. If some module is too big for you, or you find it slow, you can find something else. You can also build something for you that suits you. And yeah, those are the 5 Node.js pros for microservices. And let's see how one simple Node.js service that uses HTTP works. So this is everything that you need. I hope that the last lines can see the code. So we just need the HTTP module that's coming with Node. Then you take the create server method to run your server and to listen on some specific port. And then inside this callback function, there's what the service should do. So this one is just writing hello world. So when you hit the service, it will return you hello world back. In the middle of this, basically in the body of the callback function, you can write the whole logic of that service. And that's basically it. Your service is ready to be deployed. So here we are. So now we know how the small basic service looks like. Here are some tools that we need to add with the Node.js to make that whole microservice architecture work. So first thing is Docker. I recommend using Docker because it's a really simple tool for making containers and basically putting everything inside the container that you need, all libraries for your app. Then Kubernetes used for the container orchestration. So when you create your containers, Kubernetes helps you to scale them, to run them, to deploy them. It's not that easy to use, but it can be learned. Then the next thing is Kafka. So Apache Kafka is a messaging system that I recommend. So something like RabbitMQ or other MQ systems. Later on, we will speak more about the Kafka and the whole Elastic stack. So the company Elastic is building Elasticsearch. They also have the Elastic stack. I recommend using the whole Elastic stack for doing the logging. So when you have a bunch of small services and you push that online, you really want to see what's happening between the services. So I recommend logging all the messages that's coming there and all the errors that can happen when some message occurs. So let's go through those tools one by one. So the Docker is a tool designed to make it easier to create, deploy, and run applications using containers. So as everyone knows, what's a container? So container really allows the developer to package up an application with everything that that application needs, libraries and the other dependencies that you want to put with your application, and ship it everything as one package. So from a Docker image, you create your container that's ready to be deployed. You can replicate as much containers as you want. And Docker requires a Docker file to be included in your code. So this really is the name of the file. It's just called Docker file. And it's really simple. So here's an example of the simplest Docker file that's creating a container of the Node.js app. It can be the first one that we saw. So inside the Docker, we have those couple commands. On a Docker website, you can see all the commands that it supports. So at the top, we say from Node 8. That means find the Node 8 on a Docker Hub repository. So the repository is basically where the Docker images are living. It can be Docker Hub, it can be Elastic Container Repository on AWS. Also Google Cloud has something. There are a bunch of things that you can use. Usually those nodes or MySQL or Postgres or Mongo or those most famous images are living on Docker Hub. So at the top you say what's the parent image that you want to use, and just to extend it later. Here we want to use Node 8. You can use latest Node 10 too. Next thing, inside your container you want to create a working app directory. It can be user/app. It can be whatever you want. Next thing, you want to copy the files from your local system inside the container using the dots. So you say copy everything to everything. So copy everything to the container. You can also specify specific files that you want to copy. And you're exposing the port. So if your Node app is running on 3000, you expose that one. And at the bottom, entry point, so you just put the command that's running your app. And with this Docker file, we are ready now to build our container. So using Docker build and the dot. So dot means find the Docker file in the root and build it. You will have here between, there will be some steps that are executed, so you will see step by step how is your container being built, and at the end you have successfully built the name of the container. Here you can also specify the name of your container, but for this I just said to Docker that use some random string. So this is the name of your container that's ready on your machine and ready to be run and deployed. So how you run it? Just use docker run and the name of your container, and your container will be running on your local Docker instance. And to make sure that it's really running, you can use docker ps command that shows you that your container is running, when it's created, what command is used, what's the port where it's running, and some name that Docker gave it to. So here we basically, as developers, put our code inside the container. You build the container, and that container is ready to be sent on a server. I didn't want to show you some deployment commands that you can use, because that's basically a job of a DevOps. But you know, if you want, the next step is just putting that container on some repository like Docker Hub, and then inside your Kubernetes or any other instance that you use, you just need to pull that container, run it, replicate it, scale it, and that's it basically. Next thing, Kubernetes. So Kubernetes is an open source system for automating deployment, scaling, management of the containerized applications. Originally created by Google, and since the version 1, it's being developed by the Cloud Native organization, foundation. It's part of the Linux Open Source Foundation. So how the Kubernetes really works. So this is a kind of complicated image. Let's make it simple. So Kubernetes creates a Kubernetes cluster, and on that cluster you also have a Kubernetes master that's running. Basically the instance that you connect to if you want to do something on Kubernetes. So you can install command line locally, or on your CI, or on some deployment machine that you use, and you can connect through the Kubernetes CLI on the server and manage scale containers. So here we have the API server, some controller manager schedulers. Really doesn't matter for this talk. This is what's important for us. So Kubernetes creates nodes, basically machines that can that have containers running on it. You have as much nodes as you want, and on every node we have those pods. So pods are basically the group of containers that can communicate together. So inside those pods, we basically create our containers, and we scale them, create as much of them we want. We can kill them, deploy the new containers, the same ones, the other ones, basically do whatever we want. Next thing, so we know what are the containers, how to use them. Let's see how to make our services communicate together and what options we have there. So the service communication. As I said, there is the synchronized HTTP REST API that you can always use. It's something simplest, but you know, in that way, I think that you really create dependencies between the services, because the service has to register with some other. It has to know its API address, the port where the service is running, so it can send the HTTP request. But with the asynchronized messaging, you have the event bus. So your service only has to know where's the event bus living and what's the format of the message that the service has to send, and that's it. So there's always one service that's sending a message, the other service that's receiving a message, and also the one service can also do both things. So for the asynchronous communication, I recommend Apache Kafka. You can also use RabbitMQ, but there are some pros for the Apache Kafka. It's a distributed messaging system developed by LinkedIn for their own needs, and then they later open sourced it, and now it's licensed under Apache. So the Apache Kafka is a distributed system, which really means that you can run your event bus on different servers, real physical servers. So that's good for scaling. So if at one point you get a lot of messages, a lot of interactivity between your services, you can just put one more server in, and then your messages will be split across the service. It also, I think that there is the benchmark on LinkedIn that they did, that it can take like 1 million messages per second, so which is even more that some regular apps need. And so on Kafka, you can connect anything you want. So we can connect some apps that are sending messages, that are receiving messages. You can also create a DB. You can connect a database. You can create any other kinds of applications. So it really gives you the power to put everything on one event bus and connect everything there. Those services don't know about each other, and it's really the pure microservice architecture. All messages that are coming and living on Kafka are split in topics. So the topic is some kind of namespace where you put your messages, and the topics are split by partitions, and those partitions can be posted on a different servers too. The Kafka is also, so it's just appending on this queue the new messages, which means that really you can store your messages there for a couple days if you want to do some debugging, if you want to jump in and see what are the messages that were coming for the last 10 days. If the Kafka sees that there are a lot of messages and there is not enough space, it will start deleting the first messages that came there. And regarding the deployment on different real servers, one server is always the master server that's being connected to the other apps, and the other servers are just replicas. So the server, the main server, is just sending those older messages on the other servers. If you kill the master server, then some other server becomes a master immediately. So that's really cool. And this is just an example. So here we have, so in Kafka, your services, the Node.js services, can be producers or consumers. So producer is a service that's sending a message, and the consumer is the one that receives that. Here we have services that are doing the same job. So they are also producers, so they're sending message to Kafka, but they can also receive a message. Message is can have any content that you want, and it also has should have a name of a topic where you are sending the message. And when the consumer listening for some message, it should you should specify what topic messages you're listening to. So here's some code for Kafka. At the top there is the Kafka node library that's really mature and really good tested and fast, so you can just use it. We have a producer, so you take a producer from Kafka, create a new client. So you see here, you just only need to say this is the API address and the port where the Kafka is running, and that's it. So all services has to know just that. You create a producer from your client, and this is the object that you're going to use later. Message, so it looks something like this. It can also be just an object, or it can be an array of objects. You put a topic, so the topic is messages, for example. It can be any string. And the messages you want to send is this string. It can also be an object or an array or whatever you want to put. And you want to put this on partition 0. This is really not required, but let's say we want to put it on partition 0. So here we have a simple producer on ready callback function. So when the producer is ready to send a message, you're sending a message. If the error happens, you're logging. If no error happens, then you just console log the data that you send, basically this array. And that's it. Your message is sent to the Kafka and ready for some other service to pick it up. If some error happens, you can console log the error. The next thing, the consumer. So same thing, you require Kafka node, take a consumer, create a client, create a consumer from a client, and you say, I want to listen for messages on a partition 0. Then when some message happens with topic messages, you will receive that message here, so you can do some job. On the error, you will console log the error. Those are really those services are production ready, so this is really how the code looks like. The only thing that you change is this here, so you change the logic about what service should do. And you can also create a producer here that you can use to send message back when you're done with your work. So let's just go through the Elastic and see what the Elastic is giving us. So here we have a Kafka and all other Node.js apps that are connected to it. I recommend using Logstash, Elasticsearch, and Kibana. Those are the three apps that Elastic Stack is giving to us. So every message on Kafka will be sent to Logstash. Then, depending on a configuration file that you have on a Logstash, it will figure out if those messages have to be sent and saved to Elasticsearch or no. So Logstash is basically a middleware between Elasticsearch and Kafka that tells what messages, what topics to look for and how to save them in Elasticsearch. Elasticsearch basically saves and indexes the messages, and Kibana is the UI that helps you to just see the logs and search them. It really has a nice UI. So as I said, this is the one simple Logstash config file where we have the input and the output. Here we use the Kafka plugin and say we want to listen only for topics with the errors. So I recommend, so inside your services, you can, so inside the Logstash, you can log all the messages that are coming. And I also recommend, if some error happens in some service, also log the error on a specific topic. And in that way, on the Kibana and Elasticsearch, you will be able to just search by topic errors, and you will see all the errors that happened on your service, how they happen, when they happen, how to reproduce them. Then you can run your service locally, put that message inside your service, and try to debug that and see what really happened there. And make a fix, deploy that back to the production, and you solved one bug. The output here is Elasticsearch, so we're sending the data from topic ID errors to the Elasticsearch using HTTP protocol. Can also be many other protocol that Elasticsearch supports. And this is how Kibana looks like. So you see some metrics here, when our message is coming, what's happening. You can see the most recent messages that came in. You have this search at the top, so you can search by different patterns. There's also a language in Kibana that can help you to easily search through the logs. And we are at the end, so just one conclusion, what we were talking about today. So first thing, just use Node.js. You already know why. Use the async communication. So really leave alone the HTTP and the REST protocol. Just use a messaging system, because you saw it's really easy to maintain a lot of services. In a previous company I worked, we had more than 300 services. So when you have HTTP protocol between them, it's really hard to see what's happening. When you have just one messaging system, you can track all the things that are happening there. Use containers, so make things much easier than deploying your code to some real server. Just pack a container and using Kubernetes deploy it as one package. Use Kubernetes and log everything to Elasticsearch. So that was it. Thanks a lot.